Welcome children. In the previous session we discussed signs of trigonometric functions in first and the fourth quadrant. For fourth quadrant we took a negative angle of an acute angle, and then we saw the behavior of the trigonometric functions, what sign they are going to have. Okay. Now in the same manner it can be checked for second and third quadrant also. So this is the tabular form in which the sign of all trigonometric function in the fourth quadrant is being mentioned. Now sin x is the function which remains positive in first and second quadrant but becomes negative in the third and fourth. In the same manner we saw this, it is positive in first, negative in the fourth one. Same will be its reciprocal. As I told you, in the same manner their sign can be checked in third and second quadrant also. Now cos and sec will be positive in first and the fourth quadrant. In second and third they both are negative. Tan x is positive in first and third. In the same way cot is positive in first and third. In the remaining two quadrants, second and fourth, they both are negative. Fine. Now moving on to the domain and range of trigonometric functions. This will help you in understanding why it is trigonometric function. Okay, in functions, even in simple relations, we could define the domain and range of those relations. And the special relations which were termed as functions, for them also we were able to define the domain and range. Now this time we will be restricting to trigonometric functions. We will see what their domain and range is. And this can be understood. You can see in this table I have mentioned the domain and range of each trigonometric ratio or trigonometric function, let us say. But how it is obtained, that we will understand using the graphs I have drawn for you. Okay, so see, if I simply replace sin x and instead I write it as y is equal to sin x, and I have to find its domain and range, then what we need to do? We will see what all possible values can be assigned to x. That will define its domain. And corresponding to this value of x, what is sin x? What is the value of y? That will give us the range of the trigonometric function. That is why children, the topic is trigonometric function. Okay. For each value of x, that means for each number in the domain or value of x in the domain, there will be a unique image in the codomain. So that makes it a function. So student, let us understand what are the domain and range of all these trigonometric functions with the help of graph. Now first we'll discuss for sin x. This is the graph for sin x. You can see I have written the domain of sin x as r. If you recall the value of sin theta for the angles in the first quadrant, you must have seen sin theta was defined for all the angles from 0 to 90 degree. Not only that, in the later sessions we will learn how to convert the second, third and fourth quadrant angles into acute angle. So you will see whatever values sin x is obtaining from 0 to 90 degree, it may be same in one of the quadrants or it may be negative of those values in another quadrant, but never it will happen that you are not able to define sin x. You will be able to define sin x for every real value of x. That is why the domain of sin function is r. And you see, if you look at its graph, it is a wave-like figure, and you will see it is not breaking. See, I have not continued it further, but if we do, then you will see this will not break whatever may be x. Okay, corresponding to that there will be some value of y. So sin x is defined for all real values which x can take. But when x is taking all these real values, what is the corresponding value of y? If you again focus on this curve, you will see the highest value of this wave is at pi by 2, which is equal to 1, and its lowest value at minus pi by 2, which is minus 1. It will take this value 1 at various angles, and it will take value minus 1 also at various angles. Whenever the angle coincides with 90 degree or 270 degree, it will be taking values 1 and minus 1 respectively. But rest of the time, it is something between them. So it does not goes above 1, it does not goes below minus 1. So no matter what angle x is, the value of y is lying in this closed interval minus 1 to 1. So sin x has got maximum value 1, its minimum value is minus 1, or it can be anything in between also. So the range is minus 1 to 1, closed interval minus 1 to 1. Then moving on to cos x, even cosine of x is defined for all the real values which x can take. So its domain is R. Again look at this curve. It is again a wave-like structure. Okay, slightly different from that of sin x, but you will find a similarity here as well. It is taking maximum value which is 1 and its minimum value is minus 1 at various angles. Understood? So the range for cos x is also the closed interval from minus 1 to 1. Whatever the angle x may be, cos x will never become more than 1. It will never be less than minus 1. Then moving on to tan x. We know that tan x is not defined at certain angle. Again, you can recall whatever you have learnt in class 10. You must have seen from 0 to 90 degree. There is an angle 90 degree where we were not able to define tan theta. So same will happen here every time the angle is 90 or it is coinciding with 90. In the same way, whether it is 270 or it is coinciding with 270, you are not able to define tan x. So if I have to define its domain, I will have to remove all those angles from the set of R. So at which angles it is not defined? It is not defined at odd multiples of pi by 2. See students, I told you 90 degree in terms of radians is pi by 2. Okay. And 270 degree in terms of radians is 3 pi by 2. So pi by 2 can be written as 1 pi by 2. Okay. And 270 which is 3 pi by 2 is 3 times pi by 2. So you can see both are odd multiples of pi by 2. Okay. So all the odd multiples of pi by 2, they will either coincide with 90 degree or they will coincide with 270 degree. Let me give you some example. Pi by 2 is odd multiple of pi by 2, then 3 pi by 2, 5 pi by 2, 7 pi by 2, 9 pi by 2. These are the odd multiples of 90 degree where you are not able to define tan theta. So from the set of real numbers, the odd multiples of pi by 2 are removed. Over here, n is denoting an integer. So you can see when n will become 0, it is 1 pi by 2. You can assign negative integers also or positive. You will get the same set of angles. Now if n is replaced by 1, then this becomes 2 plus 1, 3. So 3 pi by 2. You replace n by 2, we get 5 pi by 2. You replace n by 3, we get 7 pi by 2. So you can see from the set of real numbers, the odd multiples of pi by 2 are removed. Okay, fine. When x is taking all these values, what is y becoming? Now look at this graph. Okay, this angle is 90 degree. Here it is minus 90, this is 180, this is minus 180. We know that tan 0 is 0. Only focus on first quadrant angles. Tan 0 is 0, then tan 30 is 1 by root 3, tan 45 it is 1, then tan 60 it is root 3. So as the angle is increasing, its value, the value of y is increasing. So you can see the curve is going up. But the moment x becomes 90, we are not able to define this curve. I cannot let this curve touch this dotted line because at pi by 2 we are not able to define. How big it is we cannot make out. Now if you remember in the previous session we did a result tan minus x is minus tan x. So if I start assigning negative of acute angles to tan, like tan minus 30 degree, tan minus 45 degree, tan minus 60 degree, you will see the curve will go down here. When x is negative, y is also becoming negative. And you will see more we get close to this minus pi by 2, we are not able to define. So how small will be its value? and how big it will be, its value, we cannot make out. And same type of graph is obtained for various angles. So in all these you will find the similarity in these curves. Okay, you will find whatever x may be, the value of y minimum cannot be defined, the maximum cannot be defined. It can be any real number from minus infinity to infinity. So the range of tan x becomes minus infinity to infinity. Fine. We can quickly do with this that for cot also. Okay, look at the last one. Cot x, you think at which angle cot is not defined? If we talk about the angles between 0 to 90 degree. You must have seen cot 0 degree is not defined. So whenever the angle will coincide with 0 or just opposite of it 180, okay, you will not be able to define cot. So for all the multiples of pi, cot is not defined. You replace n by 0, 0 into pi will become 0. You replace n by 1, we get pi. You replace n by 2, we get 2 pi. 2 pi is the angle which coincides with 0 only. Okay, so we need to remove all these angles for which cot x is not defined. So domain will be all real numbers except these one, the multiples of pi. Now look at the curve of tan x. See again, at minus pi I am not able to define, at 0 I am not able to define, at 0 it is not defined, at pi it is not defined. So it is taking any value from minimum to maximum. How small it will be or how big, that cannot be defined. So y can be large to any extent, small to any extent when x is taking all these values. So its range can be any real number. That means from minus infinity to infinity. Okay, then we are left with sec x and cosec x. Now cosec x, again you see, you will see the domain of cosec and cot x are same. Even cosec x is not defined at 0. Cosec is reciprocal of sine and sine 0 is 0. So cosec 0 becomes 1 over 0, which is not defined. So wherever sine becomes 0, cosec will not be defined there. So look at the curve of sine. Sine is becoming 0 at 0. It is becoming 0 at pi. It is becoming 0 at 2 pi. So at the multiples of pi, cosec is taking indeterminate form. We are not able to define it. So you will write the domain as r minus the multiples of pi. Now corresponding to this, what type of values for y you are going to get? See, even if you don't look at the graph, it is easy to understand. Whatever sin x is, cosec x will have values other than that, because cosec is reciprocal of sin x. So sin x takes the values from minus 1 to 1. So cosec x is not going to take these values at all. So from the set of real numbers, so what does it mean? Cosec x will have which values? Those which are in the complement of this, outside this. So from the set of real numbers, we remove the open interval minus 1 to 1. We keep minus 1 and 1. See, these are the common values. Sin is 1 at 90 degree. Cosec is also 1 at 90 degree. Okay. So 1 is included. In the same way, minus 1 is also included. Look at the graph. See, at pi by 2, cosec is 1. Okay. Before pi by 2 means before 90 degree, for smaller angle, its value is bigger than 1. And for the angles greater than 90 degree but 180, again its values are greater than 1. So it is becoming 1 or above 1. That is what you are getting values for it. In the same way, for some of the other angles, it has values minus 1 or below minus 1. So cosec can be 1 or above 1, or it can be minus 1 or below minus 1. It will not take the values between minus 1 and 1. So its range is all real numbers except this open interval. Okay. So this is the range for cosec x. Then moving on to sec x. Quickly recall what all angles are there for which sec is not defined. You will see sec x is not defined at 90 degree because cosec 90 is 0. So sec 90 will be 1 over 0. So sec 90 is not defined. So see the behavior, it is same as that of tan x. So wherever tan x is not defined, even sec x is not defined over there. So sec x will be defined if x is any real number except odd multiples of pi by 2. Can you see these dotted lines wherever it is drawn? These are the angles for which it is not defined. So at 90 it is not defined, at minus 90 it is not defined, at 270 it is not defined. And if you look at the plotting, you will see sec x has got the same range as cosec x. So either it is 1 and above 1 or it is minus 1 and below minus 1. So it will never take the values between minus 1 to 1. So the range of sec x is also all real numbers except minus 1 to 1.